Welcome students. Today is our lecture number 5 for the current running chapter of class 12 physics, that is electrostatics. In the previous lectures, lecture 1, lecture 2, lecture 3 and lecture 4, we have discussed about our Coulomb's law, electrostatics, the introduction of electrostatics, the charge we have discussed, next the properties of the charges and the behavior and its generation and its formation. Properties and generation and formation. Next we have discussed about the Coulomb's law, and in the last lecture number 4, we have discussed about the electric field. Previously we have discussed about the electric field. We had an introduction about the electric field, how does a charge behave, or what is electric field signifies for a particular charge. In this lecture, we will go a little bit deeper in the electric field and we will find that how does it behave and what's its nature. So let's begin to today's lecture. We have discussed in the previous lecture that the electric field is an vector quantity which is being represented by capital E and the symbol is E. The electric field is also known as electric field strength. Electric field strength. The expression for that electric field is nothing but kq by r square. Let me clear to one thing, that if there is any charge q, then that charge will have a certain field or region around it. From that particular charge, the distance is, let's suppose, r, then the electric field strength will be given by the charge and inversely proportional to the square distance between the point we are considering where the electric field is, where the value of k we have already discussed, that is 9 into 10 to the power 9. Or it was having some notation that epsilon naught, where epsilon naught value was 8.854 into 10 raised to the power minus 12. Right, now coming to the electric field, what is it indicate or what does it signify? It is the region around the charge in which the another charge will experience a force if it tries, or if there is, let's suppose, another charge q2 which is having a certain electric field around it, then if the electric field or the region of charge second will interact with electric field of charge first, it will experience an electrostatic force, and that electrostatic force was being represented by the Coulomb's, or was being given by the Coulomb's law, where the force was directly proportional to the product of the masses and inversely proportional to the square of distance between them. This was the formula for the electrostatic force in between the two charges. So these were the topics which we have discussed till the previous lecture. Now in the today's lecture, we will go through with the superposition principle of the force. Let's suppose there is a charge q1 and there are some many charges are there, q2, q3, q4 and q5, right? So let's suppose if the q1 and q2 all are of, this is my plus, this is positive, this is negative, this is positive and this is negative in the polarity. Let's suppose that q1 and q2 both are definitely will repel each other, that q1 and q3 will attract each other, q1 and q4 will repel each other, q1 and q5 will also attract each other. So we can say that F15 is the force due to force on 1 due to 5, F13 is the force on first due to 3, F14 is the force on first due to 4, and F12 due to force on first charge due to second. Now, so if I found, or if I want to calculate the net force acting on charge 1, then it will be the summation of, as it is being indicated, it will be the summation of or vector addition vector addition of the individual forces acting on it, right? We will also apply the resultant formula, that is we are aware about, that R is equals to under root of a square plus b square plus 2ab cos theta, where a and b are the two vectors which are being or considered as inclination at of an angle theta. So there will be a resultant, and that resultant will be given as under root of a square plus b square plus 2ab cos theta. So this formula will be applicable when there are two forces which are acting. Let's suppose the force F15 and the force F13 are being acted at an angle theta, right? Next, so coming to the next part of our topic, that is the properties of electric field. How does this signify, or what are the direction of the electric field, right? Now let's suppose there is a charge, that is plus q charge. This plus q charge will have certain electric field or certain field around it, which is known as to be electric field. The direction of electric field will be given for the different charges. Let's suppose for positive charge, the direction of electric field will always be outward. The direction of electric field is outward for the positive charge, and for the negative charge, the direction of electric field is always inward or towards it. Let's see the diagram. In the Q is greater than 0, that is Q is positive, then the electric field of lines will be outwards or away from the charge, or we can say that this is outwards or away from the charge. But if the Q is lesser than 0, that is negative, then the electric field will be inwards or towards it, right? So we can say that inwards or towards it. The side of arrow represent the strength of electric field. The size is representing the strength of electric field. Now look at here, students. This is a little bit thicker as compared to the previous one. It means this electric field, or this line number 1, is having lesser strength as compared to line number 2. So representation of the electric field of lines can be done. For the positive charge, it will be away from it, and for the negative charge, it will be towards to it. So representation of electric field of lines will be given, or the direction will be given by the arrow. But for a larger charges, let's suppose there is a very large charge, right? And that very large charge is having electric field for a very big region around it. So definitely the electric field of lines will follow, or we assume it, the electric field of lines will follow a straight path along it. But still, in case if they are making a turn around it, then the direction of electric field of line at a certain point will be given by the tangent drawn on that point. So you can see in the diagram, the last point, the electric field of lines do not physically exist, but they represent the real situation. It means the electric field of lines, if they are moving in a straight line, then their direction was being represented by arrow. But if they are moving in a curved manner, then the direction of electric field of lines will be tangent to it. Next, the interaction of two charges can be done on the basis of their electric field only, right? If there are two charges Q1 and Q2, and there is a certain electric field region around it, then definitely if both electric field region are interacting, then only there will be a force in between them. That force can be negative or positive, depends on the direction of electric field. Let's suppose there is a charge which is positive charge, and there is a negative charge. For the negative charge, we have read thus electric field of lines are inverse to it. For the positive charge, we have read the electric field of lines are outward to it. It means we can consider that electric field of lines are starting from positive and terminate at negative. Because अगर electric field of lines यहाँ से start हुई, then definitely for negative charge it will be inside it. So they will start from positive and they will end or terminate at negative. Right. Now, if the charges both are similar, let's suppose it is positive, this is also a positive charge, then the electric field of lines for the positive charge will be away to each other, and for the charge 2 will also be away to each other. Definitely both are coming in opposite direction. They will exert some pressure or force, and these electric field of lines will move or will tends to move away due to this force or pressure or interaction of that electric field of lines. Hence they will feel a force of repulsion in between them, whereas in the previous case they were expressing or experiencing the force of attraction in between them. Right? So I think it is clear to everyone. Let's move to the next part, that is electric dipole. We are here discussing the electric dipole. Here I will provide you a short introduction to electric dipole. What does electric dipole indicate? The electric dipole is said to be a system of two equal and opposite charges which are kept at very small distance in between them. The electric dipole is the system of two equal and opposite charges which are kept at very small distance. So this should be your proper definition for electric dipole. Right now, so whenever there is the two charges, let's suppose 2 microcoulomb and minus 2 microcoulomb are placed at 20 Armstrong distance, then definitely the whole system will be considered as electric dipole, not a single charge. Now let's come to the next property of electric field of lines. How do they behave? Let's look at here, students. Plus q charge, for positive charge the electric field of lines were outward, for negative charge they are inwards. So they will start from plus q and will terminate to minus q. But both are of the similar charge, definitely they will exert some force or the pressure and they will revert to their direction and they will experience a force of repulsion between them. Hence we can say that the like charges repel each other and the unlike charges attract each other. Is it clear to everyone? Next, electric field of lines is some properties. This is a very most important part of electric field of lines. On the basis of theory, if we consider, this is the one of those questions which are being frequently asked in your examination. Right? Now, properties of electric field of lines. There are some list of the properties. Here I will give you some about 10 properties. Among those, you need to be learn around 6 to 7 properties. Right? I'll suggest you to go through with all the 10 properties. The property number 1 says that the electric field of lines force are imaginary. They are imaginary in here. The property number 2, a unit positive charge placed in the electric field tends to follow a path along the field in which it is free to do so. It means if a unit positive charge is being placed inside an electric field, it will move towards where is the electric field of lines terminate? At negative. It means this terminal will be considered as negative and this terminal will be considered as positive. It means this positive charge is being placed, then this positive charge will move in the direction of electric field. The electric field of lines force emanate from a positive charge and they terminate to the negative charge. The tangent to that point will give its direction. Two electric field of lines never intersect each other. This is a very most important point which has been directly asked, that explain the two electric field of lines can never intersect. Why? On intersecting two electric field of lines, let's suppose E1 and E2, at that certain point of intersection they will have two direction, and one point can't have two direction at the same time. Hence they cannot intersect at a general point, right? So if they do intersect, then a point of intersection there will be two tangents. It means there will be two values of electric field at that point, which is not possible. Next, coming to the 6th point, electric field of lines are closer, means closer to the charge will be having a little bit more density or more denser, or we can say the density जितनी ज़्यादा होगी students उतनी ज़्यादा strength होगी, so they will be stronger, right? But coming to the electric field of lines which are farther, they will be more separated, or they will have some separation between them, so they will be weaker. Definitely electric field of lines has a formula, or electric strength has formula kq upon r square. It means the electric field is inversely proportional to the square of distance. As we move away from the charge, the electric field strength decreases, right? On increasing the distance, the electric field decreases. So we can see that हम जितना दूर जाते जाएंगे उतनी इलेक्ट्रिक फील्ड ऑफ लाइंस एक दूसरे से दूर होती जा रही हैं. It means they are becoming very weaker, right? Next, electric field of lines are perpendicular to the surface of the positively or negatively charged. This is the very most important property on which we will do some numericals as well. कि मेरे पास कोई भी एक कंडक्टर है, उस कंडक्टर में से इलेक्ट्रिक फील्ड ऑफ लाइंस अगर निकल रही हैं, या फिर उस कंडक्टर में से इलेक्ट्रिक फील्ड ऑफ लाइंस एंटर हो रही हैं, देन दे विल एंटर और एग्जिट एट एन एंगल ऑफ 90 डिग्री. They will be perpendicular, whether वो मेरे पास कर्व कैसा भी हो, irrespective to its shape or size, the angle of entering or exiting of electric field of lines will be perpendicular or 90 degree to the surface of the conductor. So electric field of lines will always be perpendicular to the conductor. Electric field of lines contract lengthwise to represent the attraction between the two unlike charges, and they will lateral swipe wise to pressure to show the repulsion between them. Look at here students, they are contracting to show the attraction force in between them, and they are swiping, or they are forming an area where no electric field is present. It means this is the reason where the net electric field is zero, or we can say this point or this region as a neutral point or neutral region, right? Next, coming to the next point number 10, the number of electric field of lines per unit area will represent its electric field strength. It means electric field strength is depending on the number of lines incidenting per unit area. Right? Let's take an example. This is a surface which is having area 100 meter square, right? And there are some electric field of lines which are incidenting on it, and these electric field of lines are, let's suppose, 1000 in number. So 1000 electric field of lines are incidenting on 100 meter square. So on 1 meter square, how many electric field of lines will be there? 10 electric field of lines will incident on 1 meter square, यानी कि 1 unit square पे area पे how many electric field of lines are there? 10. Similarly, coming to the another scenario, let's suppose the area is same 100 meter square, but now the strength of electric field has been increased by increasing the number of electric field of lines incidenting on it. Let's suppose there are 10,000 electric field of lines incidenting per second. It means in the second case, per unit area, how many electric field of lines incidenting? Around 100 electric field of lines are incidenting on the surface. It means that number of electric field of lines per unit area will give me the electric field strength. जितने मेरे पास number of electric field of lines per unit area ज़्यादा होंगी, strength उतनी ज़्यादा होगी. I think it is clear that in case 2, the strength, electric field strength will be larger than the electric field strength in case 1. Right? Next. One more thing, that what does EFOL represent? EFOL is electric field of lines. Next, point number 11. The electric field of lines, as we have discussed, for a conductor, they will always follow, or they will always be perpendicular to the surface. So they will always have 90 degree angle of it. So electric field of lines do not pass through a conductor. This is the property which is very much important, which is we will say it electrostatic shielding. If there is a conductor, then electric field of lines will come over it and will pass through it but the electric field inside the conductor will be zero. So for solid or hollow conductor, there will be no electric field inside it. No electric field will pass through it. The electric field will incident on one surface and will exit from another surface, but the net electric field inside the conductor will be zero. Right? Electric field of force can pass through an insulator. They can pass through an insulator, but they cannot pass through a conductor. So these were the properties of the electric field of lines which we have discussed today. I suppose that you have understood it, and please learn these all properties. So we have discussed the introduction to the electric dipole. In the next class we will discuss about electric field strength due to dipole. So from now onwards we will start with the derivative part of the chapter. And students, let me tell you that the derivations are very much important on the basis of board examination, as they are considered to be static. It means हमें सारी चीज़ें पता होंगी, डेरिवेशन हमने पहले से किए होंगे, so there will not be any manipulation in the data. नेक्स्ट क्लास में हम देखेंगे इलेक्ट्रिक फील्ड डाइपोल की वजह से. उस डाइपोल की लेट्स सपोज ये प्लस क्यू है, ये माइनस क्यू है, तो इसके एक्सिस पर इलेक्ट्रिक फील्ड कितनी होगी और इसके इक्वेटोरियल पर इलेक्ट्रिक फील्ड कितनी होगी. उसके बाद हम इसकी इलेक्ट्रिक फील्ड स्ट्रेंथ निकालेंगे एंड वी विल डिराइव द रिलेशन ऑफ इलेक्ट्रिक फील्ड एट डाइपोल एंड इलेक्ट्रिक फील्ड स्ट्रेंथ ऑफ डाइपोल एट एक्सिस एंड ऑन इट्स इक्वेटोरियल पोजीशन. So students, that's it for the day. Please be in touch. Have a nice day.